Hi, I'm an old guy and I do maths, and today I'm going to try and explain something that drives many of my students completely round the bend. They have real trouble, I think as anybody reasonably would, getting their heads around the graphs of differentials and how to understand them. So what we're going to start with is we're going to start with the equations and not the graphs. So if we just take a quadratic, y equals x squared plus 5x plus 6, and we differentiate this, the first thing that we should notice is that what we've wound up with is we've wound up with a linear equation. If we do this for a cubic, 5x squared plus 6x plus 10, what we get is we get ourselves a quadratic, 3x squared plus 10x plus 6. So the rule is that we're moving down one order. So if we have a quadratic to differentiate, we're going to wind up with a linear equation. So when we are looking at the graph of the differential of a quadratic, what we're looking at is the graph of a linear equation. And as they say on some TV shows, here's one I prepared earlier. So this is the function of x, and it's a fairly ordinary looking quadratic. And let's say we make this point here 2 and this point here 3. Okay, now what that's going to mean is that y is going to equal x minus 2 into x plus 3, which gives us a quadratic that is x squared plus x minus 6. Okay, again, not drawn to scale, please note. And we can work out the turning point of this really easily. We don't need calculus to do it. It's halfway between these two numbers. We've even got a little formula for it, which is negative b over 2a. So we can do it this way. It's negative 1 over 2. So this point here is at 1/2. The x value of this is 1/2. And we can find this other point simply by putting negative 1/2, putting that value back into this quadratic. Now, we're not, when we're dealing with quadratics, going after turning points because they're easy to find, as I said. Usually what we're doing is we're going after the gradient at a point like that or a point like that, which means that whatever this x value is, to find the gradient, we put this x value into the differential of this. And while I'm at it, I might as well write up the differential of this. So this is, I'm using function of x. Okay, f dash x is 2x plus 1. Okay, so again, this is not to scale, and the gradient clearly is not to scale, but that's kind of unimportant for the purposes of what I'm doing here. Okay, so if I wanted to know what the gradient, say, at 3 is, x equals 3, what I would do is I would put 3 into this differential, and I would get 2 times 3 is 6 plus 1 is 7. The gradient here is 7. Now, the purpose of this video is not really to go into that, but to gain an understanding of what you can read from this about this. So here goes. This tells us when the gradient is positive, negative, and equal to 0. If we solve this for 0, we get negative 1/2. Right, so this point here if we solve this for 0, we discover that this point is negative a half. And all the values of this differential graph beyond here are positive. Note here that the gradient at this point is 0, but beyond it, it is positive. The values of y that this function generates below x equals negative a half are negative. This graph is negative. It's in the negative quadrant, put it that way. Y is negative below negative a half. The gradient of this graph is 0 at this point and negative back beyond that. That's what this tells us. Now, I hope that's understandable. There's more. And this is where it really gets to be useful and at the same time slightly confusing. Right. I've got the graph of a cubic, which I think you can tell, and a quadratic. And I'm not going to go and put in too many numbers. Let's just say that this is negative, I don't know, negative 1. No, let's make it negative 2, and we'll make this positive 1. Okay, right, so here's the graph of the original function, some sort of cubic. Here is the graph of its derivative. Now, if you were to solve this derivative for 0, what you would find is that this point was 1, and that this point was negative 2. So how do we read this? Well, beyond 1 on the x-axis, the y values of this are positive. Beyond 1 on the y-axis, the gradient of this function is positive. Between 1 and negative 2, the values of y of this function are negative, and the gradient of this function is negative. At 1 and at negative 2, the value of y is 0. These are the turning points of this function. Below 2 on the x-axis, the values of y for this function are positive. The gradient of this function is positive. That's how you read this. Now, we'll probably do some more examples of this because it really can bend your mind, especially when you're given this and asked to graph or sketch a suitable graph like this. That can really do your head in. So there will be some more videos on this later on in the playlist. Anyway, I hope that this was a helpful start. Thanks very much for watching. I'll see you next time.